In order for a violation of the ambient air quality standard to be classified as exceptional, it must first meet a series of criteria. This classification can be made using the DataFed browser and tools forming a part of the Exceptional Event Decision Support System. The first of these criteria is that the event must not be reasonably controllable. This includes events such as a dust storm or a fire, both of which would increase the concentration of aerosols and gases. The next criterion is establishing a clear and causal relationship between the air quality exceedance and the event itself. This can be accomplished by using the DataFed browser. The third criterion is that the event has actually increased the concentration to above normal levels. In this example, we see that the event, the Kansas fires, located on this ozone concentration anomaly map, corresponds to this high concentration of 84 parts per billion. This concentration is far above the 3-year median of 52 parts per billion, so we can conclude that the event has increased the concentration of ozone to above normal levels. And finally, the last criterion states that the exceedance would not have occurred but for the event. The DataFed browser and datasets can be used to establish the first two criteria. Here, we see the ozone concentration exceedances, denoted by large red circles, in the month of April in 2011. These exceedances can be reviewed in conjunction with other datasets, such as the general trajectory, to establish whether the exceedance was caused by normal levels or if it meets the criteria to be classified as an exceptional event. Displayed in this first layer is the location of ozone concentrations exceeding 75 parts per billion on a given day. On April 12, 2011, we can see that there are ozone exceedances in eastern Kansas. We can select the fire pixel layer and make it visible, displaying it on the map view. The next layer displayed is the fire pixel layer, which gathers NASA's satellite data and shows that there are high levels of fire radiation. Again, there is an accumulation of fire radiation in the eastern Kansas region. The third layer shows the general trajectory, showing the flow of air towards locations where exceedances were recorded. We see here that the airflow passes through the fire zone prior to arriving at the eastern Kansas stations. This image layer from the NASA Aqua satellite shows the smoke originating from the Kansas fires. If we zoom in on the fire region, we can see the presence of smoke in the vicinity of the stations that measured concentrations above the ambient air quality standard. The most compelling evidence is contributed by the Navy Aerosol Analysis and Prediction System. This air quality model assimilates the satellite-detected fire locations and smoke optical thickness to predict the three-dimensional smoke concentration downwind from the fires. The highest concentrations of predicted smoke are found in the area of where the Kansas fires were located. In conclusion, we've illustrated a part of the Exceptional Event Decision Support System.